Section 9.1a is about prime factorization. We'll start with this sentence. When two numbers are multiplied, each number is called a factor of the product. Factors are two numbers that are multiplied to get some other number. Here we're going to take a look at the number 12. And in this example, I have 12 blocks that are arranged in a certain order. These are one block by 12. And so you can put those blocks in that order and create two factors of the number 12, 1 and 12. Well, if you rearrange the blocks evenly like this one, you'll see that it's a 2 by 6. And 2 and 6 are also factors of the number 12. There's a third way you can rearrange 12 blocks, and that's a 4 by 3. So if you look at all 6 of these numbers, you'll see that we've illustrated that those all are factors of the number 12. Now we'll look at two different kinds of numbers that we'll be using, prime numbers and composite numbers. A prime number is a whole number bigger than 1 whose only factors are 1 and itself. Numbers like 7 are prime because the only thing you can multiply to get 7 is 7 and 1. 11 is prime, 23. These are examples of prime numbers. A composite number is everything else. That's a whole number greater than 1 that has more than two factors. The 12 that we did on the last slide is like that. 100 is prime because there's other numbers you can multiply to get 100. So here we have an example of two numbers. We have to factor each number and classify them as prime or composite. Well, when you factor a number, you try to list all of the factors that make it up. Here we'll use 22. 1 and 22 are two factors of each other, so we'll list them. Are there any others? How about 2 and 11? Are there any others? And the answer is no. These are the only factors that you can multiply to get 22. Now, there's 4 of them, and if there's 4 of them, we say that this is a composite number. (31) on the other hand, you can multiply 1 and 31 to get 31, but that's it. There's no other factors that you can multiply to equal 31, so we say that 31 is prime. So listing all the factors will be able to tell you if a number is prime or composite. Our next definition is prime factorization. That's when you take a whole number and you express it as a product of factors that are all prime. So now we don't just want any factor, we only want the prime factors. The way that you do that is you create a factor tree. So you figure out what two factors multiply to get 84. 3 and 28 are two factors. Now because 3 is prime, we're going to circle it. And then we'll keep going with 28. 7 and 4. 7 is prime, so we'll circle that. And then 4 is a 2 times 2. Those are both prime, so we'll circle those. So once you get all prime numbers, you can't break them down anymore. You list them from smallest to biggest. So 2 times 2 times 3 times 7. The other way to write this, and since there's two 2's, you can do 2 squared. Either one of these answers is acceptable. So let's go over here and do negative 132. If you ever see a negative number and you write the prime factorization, one thing you should do is just break it up into negative 1 times a positive 132, and then include this negative 1 in your final answer. So now we'll just look at 132. 6 times 22 is 132. Neither of those are prime, so we'll break 6 up into 3 times 2. Both of those are prime, so we circle them. 2 times 11, and both of those are prime. So now when we list all the prime factors, make sure you include negative 1. Negative 1 times 2 times 2 times 3 times 11, or you could say negative 1 times 2 squared times 3 times 11. Now when you write something in a factored form, that's when you take a monomial and you express it as a product of prime numbers and variables, but this time no exponents can be greater than 1. So in this case you have to break anything up with exponents as well. So we're going to start with just the number 12. We'll break that up into 4 times 3, and then we'll break 4 up into 2 times 2. So we have our prime numbers. We have 2 times 2 times 3, but then we also have to break up our a's. A times A times B times B times B. This is the factored form. It has no exponents. Over here, negative 66, remember we'll take negative 1 out, and we'll just do positive 66. 6 times 11, well 11 is prime. 6 is 2 times 3. And it looks like negative 1 times 2 times 3 times 11 times P times Q times Q.